Okay, let's continue. Industrial agriculture dominates today. Now, for thousands of years, the work of cultivating, harvesting, storing, and distributing crops was performed by human and animal muscle power, only muscle power, hard labor, along with hand tools and simple machines. And this is an approach we know as traditional agriculture. The oldest form of traditional agriculture right now is called subsistence agriculture, which means only producing enough food to stay alive for themselves. As farmers begin to integrate into the market economy and to produce more and excess food to sell to earn more money, they started to think in terms of the animals for labor and produce significant quantities of irrigation water and fertilizers. So they want to have a better life, they want to earn money. So how do they do it? They're going to harness the process. Next comes the Industrial Revolution, and it introduced a very large scale of mechanization and fossil fuel combustion into agriculture, just like it did to the industry. Now farmers replaced horses and ox with machinery that provided faster and more powerful means of cultivating, harvesting, transporting, and processing of crops. Now such industrial agriculture also boosted the yields by intensifying irrigation and by introducing synthetic fertilizers. In addition, the advent of chemical pesticide reduces the competition from the weeds and the herbivory by the crop pests. The use of the machinery created a need for the highly organized approaches for farming that leads us to having to plant vast amount of areas with single crops in straight orderly rows, very organized, entropy extremely low. Now, the industrial agriculture that spread from the developed countries to the developing countries with the advent of the Green Revolution, as most of us would have known. Now, this started at the beginning of 1950 when the Green Revolution introduced new technology, crop varieties, farming practices to the developing world. Now, these advances dramatically increased yields and helped millions avoid starvation. Fewer people die of starvation, no food. But despite its success, the Green Revolution has its own price. So what price did we pay? The intensive cultivation of the monoculture using these pesticides, irrigation and chemical fertilizers has many consequences and can degrade the integrity of soil, the very foundation of our terrestrial food supply. Now, soil as a system. We generally overlook the starting complexity of soil. It's a magical carved substance. Although it is derived from rock, soil is molded by living organisms. Do you know that? By volume, soil consists very roughly of about 50% mineral water and up to 5% organic matter. The rest of it consists of pore spaces taken up by air and water. So that's why when you feel normal soil, right, you can grab it, you can squeeze some things out. It's not very hard, not like a brick. It's not that heavy. Now, the organic matter in the soil includes living and dead microorganisms, as well as the decaying material that's derived from plants and animals. It could be the insect you just step on. A single teaspoon of soil. What kind of teaspoon talking about? A single teaspoon, just estimate. It can contain millions of bacteria and thousands of fungi, algae, protists, and soil provides the habitat for earthworms, insects, termites, millipedes, centipedes, bugs, and other invertebrates. And of course, for burrowing mammals, rabbit, some rats, amphibians, reptiles. So the composition of the region's soil strongly influences its ecosystem. In fact, because soil is composed of living and non-living components that interact in complex way, soil itself meets the definition of an ecosystem. Hope you know that soil forms actually very slowly. And soil formation begins when the lithosphere's parent material is exposed to the effects of the atmosphere, the hydrosphere, the biosphere. The parent material is the base geologic material in a particular location. It may be hardened lava, volcano ash, rock, sediments deposited by glaciers, wind-blown dunes, sediments deposited by the rivers, in lakes, tributaries, or in the ocean. Bedrock is the mass of solid rock that make up the Earth's crust. The parent material is first broken down by weathering, the physical, chemical, biological processes in a three-pronged manner that convert the large rock into smaller particles. Once the weathering has produced the fine particles, the biological activity contributes to the soil formation through the deposition, decomposition, and the accumulation of organic matter. As the plants, animals, and microbes die or deposit waste, this material is incorporated amidst the weathered rock particles, mixing it with the minerals. In the decomposition, the complex organic molecules are broken down into simpler ones that the plants can take up through the roots. And partial decomposition of organic matter create humus. Humus is a dark, spongy, crumbly mass of material that is made up of complex organic compounds. The soil with high humus content holds moisture well and are very productive for plant life. Now, the weathering and accumulation of the transformation of organic matter are key processes to soil formation, but they are influenced by 5 main factors. What are these 5 factors? Climate, organisms, topography, parent material, and time. Now, for climate, soil forms faster in warm, wet climates because the heat and the moisture speed up most physical, chemical, and biological processes. For organisms, plants and decomposers add organic matter to soil. Topography, the hills and the valleys, they affect the exposure to the sun, the earth elements, the wind and water, and they influence how the soil will move. The parent material, it contributes and influences properties of the soil. Time. The soil formation can take decades, centuries, or even millennia. It's not by day, hours, or minutes, or even weeks. Not even years, we're talking about decades. And because forming just 1 inch of soil can easily require hundreds of thousands of years, we would be wise to conserve the soil as we have. Because soil is a renewable resource. It's all we think, right? It can regenerate itself for a long time, but it forms so slowly that for all the practical purpose, we cannot regain fertile soil once it has been lost. So the gist of it is, although soil is renewable, but would we want to have good soil, fertile soil, or just poor soil? Now, this is a simplified diagram to show the 4 stages of soil formation. So let's review again. So first step is the disintegrating the rock by the rain, by the movement, and then you have the parent material with organic matter decomposing and formation of the humus, mineral fragments, organic matter gathers around, and this is good for growth in plants. And for the last step, there is some development of the soil that supports the thicker vegetation because it becomes more nutritious and you have more veggies growing. Now, the soil profile consists of horizons. As the wind, the water, and the organism move and sort the fine particles that weathering creates, the distinct layers eventually develop, and each of these layers is known as the horizon. And the cross-section as a whole from the surface to the bedrock is known as a soil profile. Now, the simplest way to categorize the soil horizon is to recognize the A, B, and C horizons corresponding respectively to the topsoil, the subsoil, and the parent material. However, the soil scientists often recognize at least 3 additional horizons, but any given soil contains at least some of them. So generally, the degree of weathering and the concentration of organic matter decrease as we move downward in the soil profile. Now, the minerals are transported downward as a result of leaching. Leaching is a process whereby the solid particles are expanded or dissolved in liquid, and they are transported from one location to the other. And the soil that undergoes leaching is like a bit like, you know, those coffee grounded coffee in a drip filter, and when it rains, the water infiltrates the soil. Just think you grind the coffee, right? Then the water infiltrates it, and dissolve some of its components, and you carry them downwards. And the minerals leached from the E horizon includes iron, aluminium, silicate clay, and in some soil. And the minerals that leach from the soil may even enter the groundwater, and we know in the olden times we pumped water, drinking water from the ground, and this could cause human health risk when we drink.